Greetings, building science enthusiasts, and welcome back to the Building Science Podcast. This episode is brought to you by UltraAire, whole house ventilating dehumidifiers. Here at Positive Energy, we've been working with these dehumidifiers for years on many of our integrated mechanical designs, and we've seen such great results for both the health and comfort of our clients. We even have an UltraAire dehumidifier in our office, and we absolutely love it. When you're working with an airtight and well-insulated building, you quickly notice the outdoor air infiltration restrictions that occur, which allows pollutants and moisture levels to accumulate inside. So when you think about it, properly controlling that moisture in your home will definitely improve the effectiveness of your air sealing and insulation efforts, and will definitely improve the health and comfort for your client, your family, you. Just imagine being able to run your air conditioner at a higher temperature without feeling uncomfortable, and knowing that this improved comfort is coupled with fresh filtered air. These are just a few of the many benefits of incorporating the UltraAire dehumidifiers into your home or your project. It really is an easy choice to make. To learn more about the best strategy for controlling moisture in your home, check out ultra-aire.com, that's air with an E at the end, and see how a whole house ventilating dehumidifier can work for your home or project.
Welcome to the Building Science Podcast.
Welcome to the Building Science Podcast.
Bringing the human factor to construction, design, and architecture. Brought to you by Positive Energy in Austin, Texas.
Okay, hello, and welcome back to the Building Science Podcast. I'm Kristof Irwin, your host as always, here with my producer, Miguel.
Hello, everyone.
Today, we're going to be talking about an aspect of enclosures, right? You've heard us talk many times about enclosures, how they need to do the heavy lifting to create the interior conditions for the occupants. And as we all know, it is all about the occupants, or will be one day. So today, specifically, we're going to be talking about stucco with two colleagues of mine and experts. And stucco is a cladding system. And basically, one of its main jobs is to, besides looking lovely, it's to protect the control layers beneath, right? These are the rain, air, vapor, and thermal control layers. One of the reasons we're doing this podcast today, for those of you listening live or soon after this was released, is that next Friday, October 13th, 2017, there's a local conference, a full-day conference here in Austin, Texas about stucco. So those of you local listeners, come on. And those of you really motivated non-locals, all right, come on to Austin. It's a great city. Let's talk about stucco.
Second weekend of ACL.
And it is the second weekend of ACL. That was Matt Carlton. He's one of our guests. Matt is an engineer, and Matt, please introduce yourself briefly.
Hi, this is Matt. I'm a principal with Wisjani Elsner in Austin, and I've been working for WJE for about 22 years. My background is in structural engineering, and I got into enclosure consulting 15 or so years ago. And along the way, a lot of our work has always focused on forensic assessment of cladding systems, buildings with problems that we go in and look at and figure out how to fix. And then sometime along that process, we also started getting calls from architects that wanted some consulting from us to try to avoid some of the problems that we've been seeing.
Oh, so there's problems with stucco. Huh? Yeah. Okay, before we get into that was Brian Roeder, our second guest today. And he's an architect with Page here in Austin. We're in his conference room. Thank you.
Welcome.
And please introduce yourself.
Brian Roeder, I'm a principal here with Page. We're an architectural and engineering firm, full service. We've been practicing in Texas for over 100 years, have offices across the country, and stucco is near and dear to sort of the vocabulary of Central Texas architecture. So I guess one of my passions is if we're going to use it, let's do it right.
Yeah.
And let's make sure we get rid of all the some of the negative that's out there, because people are still doing it wrong.
Mm-hmm. Which is amazing. Yeah, so that's coming up. So we're doing this full day event, and I've been talking to people about it, and actually I've had several people say to me, how can you talk about stucco all day? You know, and the reality is you could talk about stucco all week or longer. So hopefully by the end of this episode, you listeners will get at least a sense of how it can be talked about all day, if not longer. So I'm going to start, and we're going to be talking about the very basics. We're going to start by asking you guys, what is stucco? What does it refer to? Is it a product, an assembly? Either one of you, go ahead and start.
Well, I mean, just strictly speaking from a technical sense, Portland cement plaster is referred to as stucco, and it's defined in ASTM C926. It's a mixture of Portland cement, hydrated lime, and sand. And those fundamental constituents have been that way for probably 100 years, or maybe a little over, since Portland cement was invented around the 1900 or so. They started slipping in there. Of course, it goes back thousands of years before that. Currently, our modern stucco systems are usually applied over a expanded metal lath that is fastened to the side of the backup wall, which could be a framed wall, it could be a solid wall made out of concrete block or something like that. And as a system, hopefully one of the components would include a weather barrier, flashings, and other associated features to manage water and make the building air and water tight.
Okay, good. Yeah, we'll come back to that control layer. But from an architect's perspective, is it a go-to cladding?
Well, it has its place in the market because of its cost. It's a very reasonable building skin, and so a lot of times when you're working through a project and you're dealing with the knowns, which is budget, stucco or a replacement of maybe a more expensive product does come into the conversation. And done properly, it's a very acceptable skin. The durability is well known and tested, as Matt mentioned. It's been around for quite a while in its sort of modern form. And so, from an architect's standpoint, if you can stand in front of your client and you're speaking about, well, what systems work, stucco done properly, it works, and it will provide a good skin that will perform, admirably for the life of the building.
Yeah. So it's interesting, as we've been talking about stucco getting ready for this event, I've been seeing it everywhere, and I realize it kind of goes invisible until you start to think about, like, what is that cladding? What is that on that wall? Yeah, it's everywhere. So it's been around in its current form for about 100 years. How long has it been around generally? I mean, do you have a sense of that? Big picture.
You can go way back. Certainly stucco in its sort of single coat slather formula, if you will, has been around for thousands of years over through the Romans and working its way through the centuries. That's partly why people still come to it, and they're endured by its qualities, its warmth, the timelessness that the product kind of brings to mind. And so, even though we've adapted it to sort of our modern building sources and technology, it's been around for longer than us.
Yeah, and like you said, done right, it can last a long time. And we've already alluded a couple times to it might not always be done right. Let's talk about, we know what it is, and is it all one thing? Is there one flavor of stucco, more than one flavor? Are there different types of stucco?
There are lots of types on the market, all trying to kind of find their place with the cost models that are out there. And so I kind of put it sort of three categories together. There's traditional three-coat that I think we'll talk maybe more in depth here later. And that's what most people remember, and that's what you'll see on these quality products that have stood the test of time. The market does have one-coat stucco out there, and you have to have a proper substrate, but the synthetics that are able to be derived and the chemistry behind those synthetics allows one coat to be applied, and in the market there's a place for that. There's a real sort of advantage of having a product that gets you what you need, but not at the same cost price point. And then the third bucket, and there's a bunch of derivatives of this, is EIFS, or the exterior.
Can you spell that? Or?
EIFS.
Exterior Insulation and Finish System, which most of the country calls EIFS, but in Texas we say EIFS.
Yeah, I've heard it both. EIFS.
Y'all.
Okay, so back to the synthetic. Is it still the same ingredients? It's not, right? So from a technical perspective, it's different.
Acrylic polymers are added to allow that single coat to really try to do more with less.
Is it cementitious?
It has Portland cement in it. It's heavily polymer modified, so you can think of it almost as something between something between a traditional stucco and a paint almost, because it's much thinner. The actual EIFS lamina is 3/16 of an inch, maybe 1/4 of an inch thick, or at most probably 3/16 of an inch. Whereas a traditional 3-coat stucco is 7/8 of an inch thick.
Right. Okay. Wait. So you just blurred the 3 buckets for me, though. So there's 3-coat, and then there's one coat, and then there's EIFS.
Right.
And the EIFS has the 1 coat.
But EIFS is particular because of the substrate.
Okay. Can you explain that? One of you.
Sure. Well, the insulation part, that exterior insulation and finish, that the insulation is part of an EIFS system.
Okay.
So you'll have the backup wall has a rigid insulation board that's put on first.
I see.
And then the EIFS lamina there's basically an EIFS base coat that gets troweled on the insulation, and then a fiberglass mesh that gets kind of worked into that wet base coat, and then they'll come over it with a finish coat.
Oh, it's trowel applied.
It's trowel
not
on.
sprayed on.
It is trowel. Well, they might deposit the material sometimes with a spray, but then they come back and trowel it. I think most commonly it's trowel applied. And it's
that's
just
EIFS.
That's EIFS. And it's not so a 3-coat stucco has a scratch, brown, and finish coat.
Okay.
And they call the scratch coat because it gets trowel on, and then they take a notched trowel and they make horizontal grooves in it, kind of like if you've ever set tile on a floor and you use notch trowel. Mm-hmm. And then they'll let that cure properly cure for the right moisture conditions, and we can get into that sort of stuff here in a minute. But they'll let it cure, and then they'll put the brown coat over that. And the brown coat's where they really try to make sure things are straight and true, because that's pretty much the finished surface. The finish coat is much thinner, and it's really going to give you your texture and your color. There are different pigments that can be put in the finish coat. They can use acrylic finish coats as well to give it a larger range of colors and textures.
Why is it brown? Why is the second coat brown coat?
That's the term. It's not necessarily brown. It could be formulated the same way as the first coat.
Yeah.
I always thought it was because it was supposed to be kept wet for a certain period of time or something like that.
Moist curing is part of the...
Brown coat or scratch coat and brown coat?
Well, curing is one of the fundamental heartaches and sort of difficulties of stucco. If you imagine a building construction site and the enormous areas that are being applied, you're trying to provide a semi-controlled environment, and you're outdoors, in the sun, in the dust.
And different orientations of sun.
Yeah.
The west side of the building can heat up really quickly.
Oh,
yeah, in the wind.
Oh, yeah.
And all of those are going to be these X factors on how properly the stucco is cured. Mm-hmm. And just like concrete, we want to slow cure that. We want to bring it along at a constant level and not let it sort of get these shock factors of morning sunrise that really dry it out.
Mm-hmm. Good. And so you said slow cure. What is slow? Is it a day? Is it days? If
you could get a day of moist curing, at least that's tremendous.
Mm-hmm.
I mean,
and so they have to re-wet it to accomplish this, correct? Or no?
There's a couple ways to cure. Most of the specifications that you see used today, they talk about fog curing. And it's
Excuse me, you said fog?
Fog curing.
Okay.
And it's not used often, at least not that I've seen. Matt, maybe you've seen it.
On our projects, we try to. And the other thing they can do, which really does help, is put some sort of screens up on the scaffolding. If there's scaffolding in a building, if they can at least put screens up to protect it from the wind. And then that also helps kind of contain that controlled environment that you're talking about, that they can do some fogging in there to keep that humidity level high, which if you can imagine it, in summer in Texas, you're going to cut off the wind and make it really humid in there. It's not exactly a pleasant environment to work in for the guys. But what you're doing when you're curing stucco is it's a race between the hydration of the Portland cement, which gives it the tensile strength, and the tensile stresses that develop due to drying shrinkage. Because that's one of the things that you're dealing with a Portland cement-based product like stucco, is that it's going to shrink as it dries. That makes tensile stresses and can cause cracking if it's not cured properly and if you don't have proper joints in it.
Fascinating.
A lot of times, if you're not getting fog curing in these well-defined scaffold stages that have the visqueen or the felt burlap, you're getting just essentially a wetting action. Much like a pool contractor would be trying to keep the gunite wet. They're going to re-wet that with just a sprinkler and a hose just to keep it moist. And in some cases, you're kind of dealing with the complexity of the trades that are out there and sort of the tools that they have. And that's sort of the fundamentals of finding the right contractor that really knows what they're doing and understands the nuances of why we are requesting in the specifications fog curing.
Wow. So I had thought we'd talk about this later in the failures section, but you mentioned cracking. So I've heard it described confidently by seeming experts both ways, that cracking is just an aesthetic issue and it's not a problem. And I've also heard it that it can be putting the water control under additional stress or something. Which is it?
It's both.
Okay, there you go.
First of all, you have to talk to your client and make sure they understand this product is a naturally based product, so it's not monolithic in its core. I mean, it's a mixture. A lot of times the sand is on the ground, the lime is on the ground, the cement, Portland cement's on the ground, and those guys are picking it up and mixing it. If you can get a bag mix, you can improve the consistency of your product.
Whoa, so it's not even consistent around the enclosure.
But the point to the matter is there will be cracking. There's no doubt. The question is it cracking that's expected, or is it cracking that's occurring in a non-expected manner? And that's where architects and envelope consultants talk about controlling those areas. So you're working to reduce the areas that the shrinkage cracks are going to occur. Because ultimately the crack opens up the skin to any sort of degradation of the lath, or
The skin, you mean the outer layer of the stucco?
outer layer. And that can then perpetuate, that can, continue the process of degradation. And then you start to get all the sort of nuances of efflorescence and other sort of ghosting that can start to occur by the water getting behind there.
So in terms of what Brian said about controlling the cracking, that is the term that we use. Is I think of it kind of like when you eat right and you exercise and you do all the things that are supposed to keep you healthy, and you're trying to mitigate or control the risk of a heart attack when you get to be a few years older than us.
Oh yeah,
but there's no guarantee. I mean, the trainer on TV the other day had a heart attack. I forget the guy that's on Biggest Loser.
Wow. No, I didn't know
he
that.
had a heart attack in the gym.
I didn't know that.
And conversely, you've got guys like the oldest World War II vet that's still alive, lives over here in East Austin somewhere, and he smokes a cigar every day. So there's no guarantees one way or the other, but over time, the research has shown and experience has shown that if you do these things consistently, it's going to reduce the cracking that you have. So when I say these things, I'm talking about curing, I'm talking about proper installation of the lath and the accessories, proper joint spacing, proper
Framing, subframing.
proper support.
The backing wall that you're talking
Right. So all of these measures that we incorporate into a good stucco project all contribute to a quality job. They reduce cracking. They give you a longer lasting finish on the building. And a lot of times we'll end up working on new projects with contractors that will say, well, I never do that. And it's always fine. Or my last 10 years I've been doing jobs this way and I don't do that and it's fine. Well, maybe they've gotten lucky. I can't speak to the outliers out there,
Right.
but
Yeah, some people don't wear seatbelts, right?
right, some
Still
people
alive.
get away without wearing seatbelts, but that doesn't mean that it's a good practice to do it that way.
Well, let's go into that actually. So the cracking, the quality installation depends on a lot of things being done right on a lot of different levels. In any of these three buckets, traditional 3-coat, single coat, or the EIFS. And I guess tied in here, there's a set of standards associated with these quote-unquote rules that we're going to be talking about. Yeah.
Well, that's a good starting point because the standards are even argumentative if you're out there in the field working
Really?
with contractors.
So there's like disagreement between standards.
There's disagreed.
Interesting.
How the standards are interpreted is, I guess, the biggest disagreement. And Matt talked about Lath. And here in Texas, we have a quality contracting base that includes essentially associations. So there's trade associations plus their national standards. And in the stucco world, there's ASTM. And here in Texas, there's the Texas Lath and Plaster Association. And there's essentially an ongoing debate.
Well, that's national and state too.
Right, but the national standards will apply to the product
I
here.
understand. Mm-hmm.
Ongoing debate on how to treat the control joints in the stucco and how to treat the lath behind the control joints in the stucco. Mm-hmm. So these are some of the challenges and sort of conflicts that have to be vetted out at a pre-construction meeting or in the detailing of the job, because most folks, they show an elevation, they show stucco, and they expect everything to happen as planned. But the problem is all you're asking is the finished product, and all of the mixing ingredients that get to that finished product have to be carefully selected.
And you can't really see them necessarily.
No.
I think we should actually kind of inject in here, and maybe Matt, you could do this. Could we define some terms, right? So for instance, Lath. Right?
But if
Please.
you want to go back to the beginning of your question, because Brian went right in there to one of the pressing issues in the industry.
I didn't let it out of the box yet.
Jumped in there. But if we go back to your question a minute ago.
Please.
So a modern stucco system that we commonly see on residential and commercial buildings would include some sort of framed wall, either wood or metal studs, a sheathing, which is usually 5/8 inch thick on wood. In residential projects, a lot of times it's going to have an oriented strand board or OSB sheathing, and then it'll have a weather barrier over it. The code requires 2 layers of weather barrier if it's over wood sheathing. In commercial and institutional construction, you usually see a fiberglass faced gypsum sheathing product, still about 5/8 of an inch thick. Over that, it's going to have a air and weather barrier. It only requires one, but around here, it only requires 1 layer over a gypsum-based sheathing product.
Interesting.
But around here, the standard practice is to still put 2 layers because it does a couple good things to put 2 layers over it. If you put a really nice fluid applied air and weather barrier, or a sheet applied, but a really high quality air and weather barrier, the process of fastening lath and putting accessories on the building, lath is an expanded metal mesh.
There you go. That's what I wanted to hear. It's
Okay.
like a chicken wire or something.
Well, there is chicken wire lath that gets used, and
really?
particularly,
I was
in California, in certain areas, that's the predominant kind of lath. Expanded metal lath looks like a bunch of little diamonds. If you've ever seen a pickup going down the road with a headache rack in the back that has the little diamonds on it, and this is smaller than that, but that's expanded
not
metal.
that heavy too. The ounce weight is much lighter than
Yeah, 3.4 pounds per square yard is a standard weight for an expanded metal lath. So that's got all sorts of sharp edges on it,
and the holes are about the size of a pencil or a pen.
Yeah, just about. Yeah, exactly. And so the 2 layers does a couple things. Let's say you put your really nice fluid applied air barrier on, and then you come back with what we call a paper backed lath. That's got a building paper that comes glued on the back of the expanded metal lath. And when you put that up, it creates a slit plane between the stucco and the backup wall, which kind of lets that stucco float over the surface. It's fastened, but it can expand and contract with the drying shrinkage that we talked about, and also with thermal movement, because all of these walls in Texas, a west-facing wall, even if it's a light color, it can still hit 140 or 150 degrees in the summer in the direct sun.
Yeah.
And so they can do a lot of moving back and forth, and that could be a daily cycle that wall cladding goes through. And so having that slip plane in there helps it to move. It also creates a capillary break, which allows water that goes through the stucco. Even if it goes through that building paper, it's got a drainage plane that allows it to get down to your flashing and your weeps and drain out of the wall assembly. So it serves a couple of functions to have two layers, and we certainly like that, and we see that on most commercial projects nowadays.
I mean, the two layers Matt's referring to is the building felt that's essentially behind that lath. It's sort of a standard practice, standard of care that you see for that protection and that sort of drainage plane.
Mm-hmm. But you say it's not required. It sounds like it's a darn good idea.
It is a really good idea. Technically, 2 layers is only required over wood-based sheathing, but
there's lobbying to prevent that from. Why is there pushback from the industry, or
no? I don't think so.
Intelligent people say
it's not terribly expensive to put that paperback lath on.
Yeah, but fundamentally, we don't see paperback lath specified and used as much as we just see the building paper as a secondary added.
Yeah, you could do it. So building paper and roofing felt can be used. Building paper can be used. They're both an asphalt saturated paper product. Yeah. If you do it separately, it is a little easier to, rather than having the stuff glued on the back of the lath, if you have a separate layer that's put on, it's a little easier to integrate that with your flashings and make sure everything is shingle lapped properly.
And tie your accessories to it.
Yeah,
okay.
So that does work a little better than having them come in and just put the paperback lath on. The paperback lath works fine, but it's a little bit more effort if you want to get everything properly lapped.
Got it. Good. Thank you. So before we go into control joints and lath, how would this work on a concrete block wall, a CMU wall?
Well, you can reduce the steps.
Yeah. What is that? How does that change?
There's probably still debate on whether lath is required against a block backup, but you can apply it directly to the block.
No fluid applied, no.
There is an exception in the building code. There is an exception to the requirement for weather barriers. If you're putting a stucco directly over a concrete block, you can create what's called a barrier system that's dependent on shedding all the water at the face of the masonry.
I've done it in Mexico, actually.
That is.
Does that work?
Directly applying stucco over solid mass masonry is the oldest form of stucco.
But the drainage plane gets pushed all the way to the forward face, and so
So the cracks, they're really matter then.
In like construction in old Mexico and in Italy and Rome, you're probably talking about a 16 or 18 inch thick solid mass masonry wall.
Monolithic.
So if you get a little bit of water through that stucco, it's got that wall has a huge absorption capacity, right? And then it can dry out over time. You may not have a conditioned interior space, so the wall can dry to both sides, and you don't have a huge vapor drive pulling water in. It's not like they slapped up a cellulose-faced interior wall board, and they're cooling the heck out of it, creating a huge vapor drive. So, those old school masonry walls are very durable. There's hardly any metal in them. There's nothing to corrode. If they used an old burnt lime plaster, they may have to come out and whitewash, and you'll see that on those old walls where they would come out and, once a year they'll get out and they'll kind of whitewash the walls with a new layer of lime-based plaster, and it's just they just renew their walls. It freshens them up, makes them look good, and renews the water repellency of the walls.
Yeah. So you put in something in there that I want to pull out, because you said, and they probably weren't having conditioned space inside, which reduces the vapor drive and moisture drive. So is it okay to do on a CMU wall when I do have air conditioning here deep in the heart of Texas? It's still code approved, right?
Well, you still need some insulation on that wall. It is still code.
So if it was CMU, would it be eaves?
No.
No, you could still put a standard 3-coat stucco or 1-coat
Right on
stucco.
the CMU.
Right on the
and
CMU.
then the insulation would be on the inside.
Right. Remember, a lot of times you see people that try to skim over CMU, and you get that ghosting. So the purpose to build it up and get away from a single coat or 1-coat product is to remove that potential of ghosting. And so that's the reason.
So ghosting is seeing the backing wall pattern or
seeing the joints of the block. And you want to flush struck those joints to try to make it a little bit easier for the craftsman to get a nice smooth surface.
Okay. Okay, so you have a backing wall, you have lath, you have 3 coats. That's traditional. If it's CMU, you have a backing wall, you might or might not have lath, you might have 3 coats. But then you have the second bucket, the second type, which is this single coat. How does that change on both like CMU substrate and non-CMU substrate?
Well, 1-coat stuccos they're put on similar to traditional 3-coat stuccos.
Okay.
They're called 1-coats, but really they're probably going to be at least 2.
Funny.
Instead of a scratch and a brown, you're going to do both of them at the same time.
Oh, really?
Yeah. They're thinner. They're
Like
usually
you do a whole lap of the first coat and a whole lap of the second the same day, or you do them both right at once?
Instead of a scratch and brown, you just put 1 coat on.
You're taking it out of a bucket.
And you just apply it and you
So
move on.
you put 1 coat on, and then you come back and put a finish coat over it. And so those are usually a proprietary pre-bagged mortar that probably contains some admixtures in there. Usually they're going to have a polymer modifier in them. They may have some fibers to help increase the tensile strength of the mix and keep it from just randomly cracking.
Fiberglass.
Yeah, chopped fibers. And then a lot of times they'll have an acrylic finish coat that goes over the top of it.
Wow.
And the total thickness is going to be between 3/8 of an inch and 1/2 an inch. The only form of traditional stucco that's recognized in the building code is 3-coat stucco. So the 1-coat stuccos, since they're proprietary, they have to go through a process of submitting to the International Code Council for an evaluation report. And so that's an important thing if somebody's going to be putting a proprietary, like a 1-coat stucco on their wall. They need to get a copy of that evaluation report and make sure that it's something, basically that evaluation report is something that you could give to a building official and say, here, my 1-coat stucco is approved for use under the International Building Code.
Awesome.
Sometimes stucco, like other masonry areas, are used for fire protection as well. So that's one of the reasons you need to make sure what you're using is acceptable.
Wow. Okay, so that ties into maybe a relatively timely topic in the news. EIFS is stucco over insulation, which is a petroleum derivative of some sort of. And wasn't there something in London where a building caught fire in that insulation layer? Yeah.
Yes.
It's a tragedy.
Terrible tragedy.
Was that related to code not being followed, or tell me?
Well, the report is yet to be fully published, so I think everybody needs to sort of
This is speculation, everyone.
tap and wait for the final analysis. But what it looks like is on the early onset is that the exterior insulation was a big driver of the flame spread and the flame migration up that building. The insulation is a petroleum product that ignites extremely well. And because of the vertical propagation, it was able to race through that building in record time. In fact, I think the stories are, that they just couldn't even, begin to amass it. So 2 issues there. One is the insulation. 2 is the actual skin product, which we know is a metal panel that probably more than likely did not have a fire-resistant core to the panel itself. So you have basically 2 fuel loads, the insulation and the fire core, or the non-rated fire core of the panel, that are racing their way up the building.
And just to be clear, foam plastic insulation is pretty common here in the United States. But we have, our codes here require that on a building of any significant height, more than 2 stories, I think it's 40 feet is the limit, that the cladding, if you have foam plastic insulation on your building, you have to pass a certain really pretty tough fire test. I don't think the building in London would have passed that test. So not only did it have the foam plastic insulation that Brian was saying, and it had aluminum composite metal panels with a flammable core, but they also had a big air gap between the insulation and the metal panels. Wow. And they didn't have blocks between, usually you're going to want to have some sort of fire stops in between levels of a building. One of the fundamental concepts of modern fire science is that you want to compartmentalize spaces so that if a fire gets loose in one floor or one part of a building, it can't go from floor to floor to floor up the building. And their particular design did not have those types of fire stops at the floor lines. So it was a really kind of a perfect storm of bad circumstances with the flammable insulation, the airspace that acted like a chimney, and it just convected a huge amount of hot gases up that just spread the fire throughout the cladding system, and the flammable exterior face and the lack of fire stops. So all those things together are, were really a terrible situation, and I'm pretty confident that our fire codes in the United States, that system would never have passed. The one we're talking about is NFPA 285 testing, and it would never have passed that.
It was a reskin, so
was it reskin of an existing?
The fire stopping or the floor stopping that we normally see in a curtain wall or a high-rise building where every floor is stopped. That was not performed as part of the reskinning effort. They might have actually had the stopping in the original skin, but it didn't matter at that point.
Wow. But let's talk about stucco. I'm assuming that massive flammability is not a typical stucco failure. Go ahead.
It's not. The failures are sometimes judgmental of what classifies a failure. Again,
interesting.
we talked earlier about sort of informing your clients on what to expect, and it's getting that phone call, maybe a couple years or even the first year, and just saying, "Hey, I've got this crack. What do you think?" And so you, as sort of a building science guy, you go out there and you look at it and you begin to evaluate, well, is this a systemic condition or is this just something that's just popped up? And sometimes that telltale first crack can be a sign that something else is happening, like moisture is getting behind the stucco at some point. I know Matt and I just looked at a property a couple months ago, and the failure was actually at the coping, at the top of the roof. There were some other issues in the project, but that fundamental flaw was not a flaw by the stucco installer or the stucco contractor. It was a flaw by the roofer, and their ability to sort of complete that skin all the way to its closure point. The water is going to want to drive its way out, and it's going to want to go through the easiest path. And sometimes it gets caught between there, and in that case, it was trying to push its way out of the stucco. So you get this sort of, I don't know what's the technical term? You get this ghosting, essentially, that starts to occur as it's driving those salts out of the Portland cement mixture towards the exterior surface.
Good.
Efflorescence, that's what you were looking for.
Efflorescence. Yeah. So I realized actually we didn't go through the control joints in the Lath installation,
but we skipped that. Remember?
Yeah, those are going to be woven into the failures, right? Like if you have a punched opening, if you always see stucco cracks at the corners of it or something, that might be something with how the Lath was installed. Or
these are going back to these X factors in this checklist, and sort of the regimented approach that you have to just sort of discipline the project to. And if you're not disciplining the project to certain standards, you're opening yourselves up for these X factors. Like, oh, well, we didn't tie those accessories. We just tied them maybe every 12 inches.
What would be an accessory? Excuse me.
An accessory is like either it could be a decorative joint or it could be an actual control joint. These are bent metal pieces. Sometimes they're aluminum extruded pieces, but any sort of accessory has to tie into that lath. You can't expect the stucco to remain part of the system unless it's all part of this continuous lath. And there's a lot of tedious work that goes into tying and screwing all that together.
Wow.
And in the age of let's put this up and we got to open tomorrow and it's September 21st, we got 1 week to go, those are where the shortcuts maybe start to come into the play.
What about fastening the lath?
So the lath, and I guess just to back up with
Please.
the accessories, as Brian mentioned, you've got control joints, and that's usually sort of a W-shaped piece of metal. If you cut it in cross-section to look at it, it's sort of W-shaped. That gets fastened to the building, and again, it's an interruption. It's intended to be an interruption in the plane of the stucco that allows it to expand and contract.
To prevent cracking.
Yes. If you don't do that, it will create its own joints, which are called cracks, right? Except they're not nice and straight and neat, and architects don't like that.
Right.
And building owners don't like it either. Another common type of accessory is a casing bead. So it's a sort of a J-shaped piece of metal that gets put around framed openings like windows and doors, and it gives you a nice clean place to stop the stucco. The stucco gets troweled into it. It helps set the depth of the stucco so you get the right thickness. And then it creates a nice edge for you to put a sealant joint between the stucco and the window or door or other interruption. And that's super important because that window or door is attached to the building frame and it's not moving. And as the stucco expands and contracts, you need it to be isolated from that dissimilar material. Because if you don't, it gets bound up on it, right? And then as the stucco needs to move, it's being restrained by that window or door, and it could cause cracking. And then the other thing that could happen is you could just get water in. If it separates from it, you could get a lot of water in that space. Backing up to...
go ahead.
Don't forget weep screeds.
I was about to say the bottom of the wall.
Weep screeds, yeah. And absolutely, it's important to provide drainage.
Because the water goes through stucco. I think a lot of people don't realize that.
Well, some water goes through stucco. Hopefully, most of the water is shed at the face of the stucco. Yeah. You do provide that weather barrier back there that's intended for incidental water that gets through the stucco. It's important to control the cracking and to have good jointing because you want 95% of the water to be shed at the face of the stucco. And the reason for that is that you have to attach that lath at 7 inches on center at every stud. Think how many 1,000 fasteners that is in any given wall. So yeah, you put a high quality weather barrier on it and hopefully it's got some ability to seal around the fasteners that you put in there, but you're still poking a whole bunch of holes in it. And
you're doing also a blind fastener at that point because you've got your building paper, your building felt that's essentially black, right?
And if you miss, do you pull the fastener out?
Well, that's another podcast. But you're not getting the nice gasketing that all of the weather barriers have been tested to. There's a nail sealability test, and all the manufacturers can pass it because it's a 8-penny nail or whatever that's driven in at a very precise 90-degree angle to the substrate and oh yeah, it passes the nail sealability test. But that doesn't happen with lath. Remember, this expanded mesh is diamonds that are all sort of contorted because they need to have that tooth to grip the Portland cement mixture that's it's got to get troweled onto. Yeah. And so your fasteners actually, a lot of times, in the case of many installations, it's driven at a slight angle or it's held off because the lath is in between it. So that's why having some sort of meat or thickness to that weather barrier helps in stucco applications to give you a little bit of redundancy for that nail sealability.
This is awesome. I mean, you definitely can say you can talk about this all day. So, all right, so let's get back to where we were on that topic of the way you install the control joints and the way you install the lath impacts the failures you might see.
Well, it's your structure, it's your bone, it's your skeletal system, right? So you want to have solid bones, right? You don't want any breaks in your bones, or the breaks that you do, you want to be sure about it. So we mentioned earlier sort of the industry standards that are out there that are written into the specifications have a very regimented certain way of how things are being installed. And Matt sort of touched on, the spacing. All of these things matter, and people should recognize that you see a guy out there with a ruler measuring the spacing of wire ties or the spacing of fasteners. It's there for a reason. It's not to make people's life miserable by counting fasteners. It's generally these are the predicted areas that you have to put the fasteners. And so back to the standards, there's an ongoing debate on whether or not a control joint is receiving all of the pressure of the stucco expanding and contracting, and therefore does the lath have to be broken behind the control joint?
Does it, Matt?
Well, so per one of the standards that Brian is talking about.
Which one?
And
It's
that's
okay to say.
ASTM C1063. Yeah, non-proprietary. So ASTM C1063 is referenced in the building code, so it's not optional. It's something that contractors are required to comply with. That requires that the lath be interrupted at these control joints, and the intent of that is to truly free up the joint so that it can expand and contract. If you think about it, if you're trying to allow something to move, you're not going to put reinforcement across it to pin it together, right? So it really doesn't work unless you interrupt the lath. As an engineer, to me, I tend to think about stucco like a concrete slab on a wall, and so oftentimes, you will go ahead and clip every other bar at a contraction joint and a slab. You'll do something to intentionally weaken that plane, because if you just looked at the transformed area, if I can throw out an engineering term, if you look at the actual stiffness of the steel wires crossing that joint versus the tensile strength and the stiffness of the stucco, the wire just dwarfs. The stucco is not a strong material. Steel is 36,000 pounds per square inch of tensile strength, right? So you can put a joint in a wall, but unless you actually interrupt the steel crossing the joint, the stucco doesn't know that it's there, and it doesn't allow it to move like you want it to. Now the contractors around here, and the controversy, there's an argument against it. Many of the contractors in Texas don't like cutting the lath, and they will swear up and down that they shouldn't have to do it. The reason they don't like doing it is because it's just way easier to run long sheets of lath all the way down the wall, and then to get a control joint with what they call the thickness of the accessory is called the ground, the ground depth. And instead of getting a 7/8 inch accessory and putting it on first and running the lath up to it, or just cutting the lath and putting the joint thinner ground on top of it, they like to just run the lath across the wall in big sheets because they can get a lot of production that way, and then they like to tie the accessory on top of it. They like to tie the joint on top of it, a thinner joint. And because the lath is furred out, they use a thinner joint right there. It's just more work for them to put it up and come back and try to snip the lath, or to cut the lath first and put it up and align all the cut ends in a perfect straight edge right where that control joint is going to be, right? That requires taking a tape measure out, measuring every sheet of lath. And so it is more work for them to cut the lath there. And many of them have gotten away without doing it on projects, and maybe they haven't noticed cracking on those particular projects. And so, from their standpoint, I believe that they believe what they're saying when they think it doesn't make a difference. But again, it's like I was saying when we started out, we know it's good practice. We know it reduces cracking. Yes, they may have gotten away with it a couple of times, but from our standpoint, we know it's one of those good practices.
Well said. So Brian, from the user specifier perspective, are you do you say things to your clients along the lines of, well, if we don't cut the control joints, we can save a little bit of money?
That never comes into the conversation. I mean, they're expecting a building that has stucco and brick and stone and glass, and that's what I kind of start off with. If we're architects and we have this palette of materials to use, we should be able to use stucco correctly, and we should install it correctly, and that's what the owner, is expecting. I think I'm going to rely on the institutional standards and, carefully selecting good consultants that help us kind of reinforce that standard out there in the field, because again, of the 10 different X factors that could go into achieving a good or not so good installation, we're going to try to check off as many of those boxes as we can.
Okay, so as you say, some of the things for a different podcast, because one would be if Page specifies it and the general contractor agrees to it, but the installer doesn't do it, where did the communication break down? But that is a different...
Happens all the time.
It does. Okay. And
Yeah, the blanket spec out there. Right
Not
now,
with Page, but I mean,
Oh, of
in general,
course.
it happens all the time.
the blanket spec has 1063 written all over it. And
So then if there
it's
is a
reference.
failure and it's determined that a control joint isn't functioning properly, and I guess that failure would be like more cracking than typical? Or?
Well, you should be out there looking at the product as it's going on, as the lath going on, so you catch that before it happens.
Yeah. So emerging trends in stucco, is it moving toward like EIFS is starting to dominate? I know continuous insulation is much more of a code requirement now.
Right.
Anything about stucco? And
I think it's entirely likely that we'll see more EIFS on buildings. EIFS got a black eye 20 years ago when it was first starting to be used in this country, maybe more than 20 years ago, 30 years ago.
in the 80s, yeah.
It got a black eye because of the systems that they were using and the way that they were putting them on. And the EIFS systems that are out today are different.
In fact, they got renamed. Didn't someone say there's like a...
Yes, there are some different names that they're...
CIFS.
Yes, there are some different names because
CIFS.
there were actually insurance companies out there that were telling contractors that we're not going to insure your projects if you build them with EIFS on them. And
So you rebrand.
yeah, so they're doing a reboot.
CIFS is continuous insulation finish system.
Right, but
Yes.
the fundamental is that a drainage plane has been created at the backside of the new installation. That's the big idea, if you will, that took
and
care.
flashings at openings. And
Well,
such, yeah.
we should have had those in the 1980s too.
Exactly.
But, without that drainage plane, it was just like a sponge, and anything that got behind it, it would just transmit that moisture to the back. So, the new systems have their place in the market, and it is difficult to do, or more difficult, I should say, to do traditional 3-coat stucco over continuous insulation. There's some nuances that have to be worked out, and the ability to do that off of Z-girt or other means. There's thermal breaks that start to occur there. So I think the industry will find its balance point between EIFS and traditional. Because CI, continuous insulation, is not going away. It's only going to increase every building cycle.
And neither is stucco is going away. So let's do two last definitions to wrap up here. So Brian, you just used the word Z-girt. Is that a new type of yogurt? Or what is a Z-girt?
Yeah, it's Greek. It's vanilla with strawberries on the bottom. But, Z-girts are commonly used in Texas. I know maybe some of your other listeners are in other parts of the country where thermal breaks have become a big issue. In Texas, the contributing factor is known. It is there's been plenty of white paper research that the Z-girt is just basically a bent piece of metal that's holding off the face of the sub sheathing, whatever skin it is. It could be metal panels, it could be stucco, it could be.
So the stucco is the cladding. It's heavy, and it has to get its support all the way through the insulation, way back at the structural wall.
That's right, but
And
that's
that class of product is called a Z-girt.
that's right, and there's engineering that proves out that transfer load path all the way
There's
back.
different types.
Right, and what Brian's describing, the bent piece of sheet metal in a Z shape that gets fastened on the wall, that's a Z-girt. The other kinds of systems that are out there, and there are several that are being marketed now, have generally some sort of composite material
For thermal, to prevent thermal transfer.
a low conductivity material that is intended to prevent the transfer of thermal energy through that insulation. And then a lot of people are also fastening their stucco directly through the insulation into
Which is long fasteners.
with long fasteners and big discs on the end. And there's some research out there that supports the idea of being able to do that. I think we're going to have to see over time how well that works, whether or not you have some support issues that develop over time. But there's some testing that's been done that says that that's okay. So there are papers out there. As Brian said, this is an evolving building construction doesn't move super quick.
No.
And a lot of times people will rush out and adopt a new system, and it has to be in place for a few years for the problems to start to show up.
Yeah.
And so some of the things that are being tried for attaching stucco, we're still kind of trying those things. They're sort of in their trial period, and we'll see how they work.
Awesome, thank you. Okay, so your vocabulary lesson is something you threw out a long time back. I've always been wanting to ask about this and put you on the spot a little bit. So you mentioned that in the synthetic stucco, they can have this admix, and the admix might include polymer modifiers. And you just kept going. So could you get in a little bit what a polymer modifier is or does? Or
Sure. A polymer, like one common type.
So, actually, define polymer if you wouldn't mind.
A polymer is a synthetic molecule. Well, I suppose it could be an organic molecule, but it's kind of like a glue.
So it's a polymer.
It's simple, right?
Many mers.
Like plastic is a polymer, fundamentally, right? Rubber is a polymer. That's a generic term.
Because there's one molecule repeated many times.
Right, and usually it's a hydrocarbon molecule, and you can take the hydrocarbon molecule and string it together. And that's what's great about carbon, hydrogen, and oxygen is if you look at all the different things that can be built out of those molecules, it's millions probably of different products that are built out of those hydrocarbon chains.
So it's a polymer. That's a polymer.
Right, and so one of the more common polymers that's added to stucco and eaves is a latex, and so it's basically like a liquid rubber that gets mixed in there, and it replaces some of the water in the Portland cement mix, and it helps make it less permeable. It helps to improve bond strength between layers. It reduces shrinkage. So it's a good thing. And that's how, when they add that polymer, they're able to use thinner layers for the one-coat systems and for the exterior insulation and finish systems.
Also, color retention is improved. That's one thing that people don't think about sometimes. You have to make a fundamental decision from the get-go when you're specifying stucco is what sort of finish coat are you looking for? Are you looking for that old feel that has some variation in color, or a monolithic sort of color fast system? And then some of these finish coat systems have an elastomeric property to them that will allow that latex, if you will, to bridge small gaps, small cracks. And so that's another level of sort of protection that you can provide, and it's also how a lot of stucco that begins to see some failure is mitigated with a new finish coat that has some of those elastomeric properties.
And the color matching can be an issue, right? If you do like color integral stucco, in the
it's huge because it's just like if you ever try to do a large cement placement or concrete placement, they want the batch plant to be queued up, to be continuous on that project until we stop. And that's what happens on a stucco project as well. It rained the night before, so the sand that the guys are using the day after the rain has a little bit different content, or maybe a little bit of something happened to the hydrated lime, and you can get some color variation. But to others, that's actually part of the seductiveness of that old world feel, and they're totally good with it. But clients have to understand what they're buying. Are they buying a color fast stucco finish coat, or they're getting that sort of color embedded?
What looks good on a Mediterranean villa may not look good on a super modern building, right?
Yeah, more color integral. Wow. Well, there you go, listeners. There's a lot to say about stucco. Thank you guys very much today for your time.
You're welcome.
Thanks for having us.
Okay, thank you guys very much again for listening, and don't forget to look at the show notes. There's a link to this stucco seminar coming up next Friday the 13th, boom, here in Austin. Hope to see you there.